Question number 26. A car of mass 1100 kg starts from rest at O and travels along a road OAB. The section OA is straight, of length 1760 meters, inclined to the horizontal with A at height of 160 meters above the level of A. The section AB is straight and horizontal. While the car is moving, the driving force of the car is 1800 newtons and the resistance to the car motion is 700 newtons. The speed of the car is V meters per second when the car has traveled a distance of X from O. So whatever is X, we don't know, it's just the distance from O. For the car's motion from O to A, write down the increase in kinetic energy in terms of P. Let's do that. Okay, so let's say this is the distance X covered, then the speed here would be V, and we need the increase in kinetic energy, which is going to be half times m, which is 1100, times difference in the speeds, square of difference in the speed. So v square is the higher speed minus 0 squared is the lower speed. So this comes out to be 550 v square. That's an expression for increase in kinetic energy in terms of v. And we also need the expression for its increase in potential energy in terms of x, where x is this distance. Okay, so increase in potential energy is mgh, where h is the difference of height between the two levels. So if this is the distance x covered, then this will be the vertical height, and this would be x sine theta. Okay, so mgh, m is 1100, g is 10, height is x sine theta. Okay. So sine theta can be found using this triangle. So sine theta equals 17 or 160 over 1760. Simplify this. Let's see what we get. We get 1 by 11. So we're going to write 1 by 11 here. And this becomes 1100 into 10 into 1 by 11 is 1000x, which is the increase in kinetic energy, potential energy, sorry. Okay. Hence, find the value of k for which kv square is equals to x. Okay. Now I need an equation that would connect these somehow. And in it, I'm going to replace x with kv square. Okay. So we're going to use the conservation of energy formula, work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Work done by driving force would be, this is the driving force, 1800 times x, which is the distance covered, plus uh, loss in energy. Potential energy has increased and kinetic energy has also increased, so there's no loss in energy, so 0 here, is equals to work done by resisting force. The resistance is 700 newtons and the distance covered is x, plus gain in energy. Both of the energies, the kinetic energy and potential energy, are increasing. So there are two gains, 550 v square plus 1000x. Okay, now we have an equation that has v and x in it. Now we're going to use this. Kv square is equals to x. All right, so let's simplify this and let's then see what is k coming out to be. Okay, so what we'll do in this equation, we'll make x the subject and we should get something like this. and the coefficient of v square will be the k for us. Okay, so to make x the subject, move all x terms to the same side. So we have 1800x minus 700x minus 1000x is equals to 550 v square. Okay, we get 100x here is equals to 550 v square, and then we get 5.5 v square, which means that k is equals to 5.5. Okay. Next, it says that show that v square is equals to 2x minus 3200 for x is greater than equals to 1760. Okay, so when x is greater than 1760, that means that we're talking about the horizontal line. So it's somewhere over here. But for this region, from A to B, in fact, the distance will not be represented by x now. It'll be represented by x minus 1760. You will subtract this from x. So instead of x, you're going to use x minus 1760 for this part. Okay, so let's apply the work distance, work energy formula here as well, which is going to be work done by driving force plus loss in energy is equals to work done by resisting force plus gain in energy. Okay, work done by driving force would be again the driving force is 1800 and the distance is x minus 1760. Plus loss in energy. Okay, so I think that's still going to be zero because it's a horizontal line. The potential energy will not increase or decrease here. So that's just going to be zero. Is equals to work done by resisting force, which is the resistance times distance, which is x minus 1760. Plus gain in energy. So kinetic energy gain is going to be half times m times difference in V at uh, between the value here. Let's say this is the distance covered. So we need V here, we're calling it V, and we need the speed here at the top first. Okay, how do we find the speed here? That would be through this formula, kv square is equals to x. Yes. Okay. So for this part, for the first part of the journey, we know kv square is equals to x. Our k came out to be 5.5 times v square equals to the total distance from the bottom to the top is 1760. This will give us v square and we will use v square. So no need to square root. 1760 divided by 5.5 is coming out to be 320. Yes. So v square here is coming out to be 320. So the speed here, if it's that represented by v, square it minus this speed, the square of this speed, which is 320. Okay, so this is the equation that you'll solve, and you should be able to get this. V square is equals to 2x minus 3200. Let's see if we get it or not. Okay, m is 1100, so this needs to be fixed. Okay, so this becomes 1800x minus 1800 into 1760. It's a big value. 3168000 is equals to 700x minus 700 into 1760 plus 1100, oops, plus where were we? 0.5 times 1100, 550 v square minus zero point 0.5 into 1100 into 320 is this. Okay, now move the x terms to the same side. Now move the v square terms to one side, and that is going to be this. This stays here, and move all the x terms towards the left and all the constants towards the left. Okay, let's see what do we get. We have 1800 towards the left already, minus 700. So we get 1100x. Okay, next we have minus 3168, three zeros towards the left already, plus 1232, three zeros, plus 176, three zeros. I'm getting minus 176, four zeros is equals to 550 v square. Okay, divide 550 on both sides. We get this, which is the correct required form.